YouTube, Electric Adventures here with the next video in Electric Adventures The Games. We've moved on to Program Pack 10, which only has 2 games on it, but they're much larger games. The first one's called Gold Rush, and the second one's called Pyramid. So in this episode we'll have a look at Gold Rush. So back in the day, I used to love the game Manic Minor, and always wanted it on my system. So when I had my original Spectravideo, I wrote my own, and it was called Gold Rush. So this is a slightly later on game. I can't tell you exactly when it was released. So we have some more detailed titles, a high score table, and a press trigger to begin. So not using tiles or anything, so we're just using drawing. Although, well, actually, no, we are using some tiles. Okay, so we have our little man. We can move, and we need to get across. Well, we can't make that leap. I'll play this for ages. Whoops! And any little touch, and you die, just like Manic Minor. So pixel perfect. Only got 2 frames of animation for our guy. And you do have melting platforms, so we need to go up here and get up into this platform. Actually, I'm sure we're probably supposed to make our way across, so we better do that. No, I've messed up. And if you do mess up, the only way you can fix it is by killing yourself, just like in Manic Minor. I obviously haven't played this for a little while. I'm sure you've got to get that one up on the top right later. Now I've got to get across here. Whoops, didn't time that very well. And we've got a maximum fall distance as well. I'm actually trying to figure out my own game here. I've made it fairly hard. Oh! 1 life left, do we? So it's got 10 different levels. So quite a challenge. Oops. Oh, I fell too far. I'm going to have a second go. I've become crap at my own game. It'll probably be pretty rubbish at Manic Minor as well. But it's showing, you know, it's all written in BASIC, so it's all... Well, that was close. It shows what you can achieve. I'm just going to try... I reckon we can make it up there. We can too. Now let's go over here. Oh, I was too slow. So just like Manic Minor. Fascinated with, you know, pixel perfect platform games. Well, you can make that, okay. Now the interesting question is, can we make that? No, so we actually need to go back to there. That's okay. I'm starting to get the idea of which way you've got to go now. I just need to make sure that I make this last jump. Actually stuck in the wall there a bit. And then the exit flashes. And we get a bonus for the amount of time we took. And we draw our next level, and we've got to figure that out. So different things, always got a bouncing ball, always got destructible platforms to get past. Oops. Can't make that one. Oh! Enough pixel perfect jumping to send anybody. I thought that was going to be a destructible platform. This one. Ow! How to miss? I'm going to hit that under all. Right, so this is a permanent platform, so I don't need to worry about that one. Okay, how are we going to do this? Right, so that gets rid of those two. Pardon me. Sneak under our ball here. Sneak under the ball again. Oh, I missed the platform. Oh dear. Well, you can see where we're going there. So, and there are 10 actual levels that I designed and planned out. So it made it, you know, quite a decent little Manic Minor game. All right, I'll get set up and we can have a look through the code. The code of this one's a bit bigger than the last few games. Right, here we are looking at the code. So let's do our list and see how long it is. So we're going to assume this one's going to be a bit bigger than the last game. And fairly large lines too by the looks of it. Still going. Got a bit of data at the end. Alright, so 87 lines long. Oh, that's a bit too... I told you they look like big lines. There we go. So our usual first line, so clear some memory, set our default colour at screen mode, set all variables to integer to make them faster, create our random function and open our handle to the screen. Line 20, we go and set the colour on the screen again, we reduce that definition down so Z is no longer a, an integer variable. We define our random function again for some reason. Bit of duplicate code here, interesting. And then we initialize the high score table with just dots in all of the names. So we got rid of 5 of those. Line 30 we restore to the start of our data. And we've got 8, I take it, sprites we're going to read in. So we read those in and we use the sprite statement to assign them to a particular sprite. Sprite shape anyway, and then we have a 4x8 array which we read in the data in as well. I take it there, that's our level data. So line 40, we clear the screen, set a colour, and then we do a draw command. I don't think I've covered the draw command very much, but it's like Turtle logo language. It was also, this particular instruction was actually first on the TRS-80 Color computer, whose BASIC preceded MSX BASIC, or Spectravideo then MSX BASIC. So they both have this particular thing. Each of them is a set of instructions. You have a 1 or 2 letter command, and then maybe some coordinates or measurements after each one of them. So I'm not sure what the BM, but move probably means to go to 60, 0. Once again, my memory's a little lacking, but I know R is right. Indeed, I can't remember all the commands. I'd have to look up some of them. But this is basically going to draw our gold rush figure that you see. Yeah, so the first one is gold and the second one is rush, I would assume. We'll keep our line numbers short here because they're going to be quite big. So line 50, we put up the letters high score. We draw a box that's unfilled and we output what the current high score table inside that box. And then we put our press trigger to begin. Line 60, we're looking for either the keyboard or the joystick and port 1's button to be pressed, otherwise we just go around in circles. Otherwise we clear the screen and set up our variables for our game. So ZS is our score, LV's lives, LL would be our level. Not sure about SC and EM. Extra man, it would be the EM, that's usually what I used EM for, extra man flag. And then we draw a filled box in the coloured blue all over the screen. You see that as it runs, and then we draw another box which is black inside that one, thus putting our border all the way around the screen quickly. And then we draw another box down the bottom which is going to be our scoring area. Now 970 we print all of the, we set up all of that area, so we've got the score just with zeros in it to start with, the screen we're on, the level we're on, and then we call a couple of go subs, 280 and 300, which will probably update the lives and the score. And then the for statement is probably poking directly into our name table in video memory, the character that you see going along the bottom, and you can actually see that being drawn when the game runs. Sorry, I'm just checking to make sure I'm telling you the right thing. So that, yeah, that draws those characters in there, and then it is actually going through our array, drawing various platforms and characters around the screen. So it's using our array data, which we'll get to a little bit later. So we want 80 to 100 this time. Okay, line 80, we're just seeing BC to 5. We're clearing out our sound register. Now I know. Yes, that load on the previous thing wasn't actually drawing characters, it was actually setting the shapes of the tiles to the data at the end. That'll become clearer when we look at the data at the end. So those different shapes that I've used for each of the things the characters land on during the game are all out of that array. And we're putting them into video memory. Now the TMS 9918A graphics chip has 768 positions on the screen, and you can set them to one of 256 tiles, but you have 3 sets of tiles, one for the top half, one for the middle half, and one for the bottom half, which is why we actually go through that loop so many times to set all those. So basically we're setting the same set of tiles for each section of the screen, and then we can just refer to them by number. Now, sorry, back to our line 80. Right, we print. That's our screen, I would say, to take it. Print our screen number, and then we use the on the SC go sub to go to a particular line to set up for that screen. So rather than data, we've actually got a block of code to draw each of the screens. We put our man sprite at the current value of X, and we probably set that X inside that subroutine. We set our current Y value. G was probably the number of pieces of gold we've collected. Not sure about F and C. And then we set on sprite go sub. So basically when any two sprites collide, we'll go to that subroutine. And that's a quick way of doing collision detection. Although it just tells you two sprites have collided, it doesn't actually tell you which one, so you've then got to go and check. So line 90 we turn sprite on, which means it turns on that collision detection. For some reason we put sprite 0 again, and we grab both of the stick, the inbuilt stick that's built into the keyboard, which is the cursor keys or the red joystick on the original Spectravideo, and the stick from in joystick port 1, and we see if it equals 0, which is basically, I think that's left. And then we look for 3, and then we do we look at the point in that direction to the right. 0 would be up. I'll have to test out what up does. But anyway, right, it sets a direction, but it also looks to see whether there is actually a point to the right, so we can actually go right. And if it's black, so if point equals 1, point brings back the colour of the pixel. So if it's black, it's okay for us to go to the right. We increase our X by 4, and then our C, if C equals 0, then C equals 1, C equals 0 would be flipping our animation shape between two different sprite characters we have. Line 100, if A equals 7, that's to the left, then direction equals 2, and we're looking for the point to the very left of the character. We're looking at the left at the foot of the character. If that's black, then it's okay to go to the left. We decrease our X, and once again we flip our character so that we have a walking motion. Right, 110, we reset our sound, and we look for either the keyboard joystick button, which is the space bar, or the joystick button in joystick 1. And yeah, okay, I think those previous ones were recording the direction. So if you press up, it resets your jump direction. That's what it does, because otherwise you would just jump the last way that you moved. So by pressing up, it allows you to reset which direction you're going to jump, so that way you can just jump straight up. Now it makes sense. I've got to remember, I haven't looked at the source code for about 30 years. Okay, so F is probably our variable to say whether we're actually jumping. So we set it to 1, we start a sound, and we set another Y variable with our current Y. I suppose if we can return back to the same point. A couple of variables, and then we're flipping the FF variable. Line 120, if F equals 1, that means we're jumping. Then we decrease our Y, we're going up, and we decrease our sound, so that makes our sound goes up. And HH is how high we've jumped. Once we get to 6 increments, then we set F to 2, which is obviously our mode. It sets us to be falling, and jump to 140 so we don't directly start going down again. 130, if we're in F mode equals 2, which means we're falling, we increase our Y and change our sound accordingly. Which also, same on the previous line, we also change our X if we're previously jumping in a left or right direction. There's a lot of code in a very little space here. We check to see whether there is black to either side of us, otherwise we stop moving. Line 140, so this is FF, and point equals 4, or point equals, so we're looking at 2 spots on us to see whether we're, I suppose, yeah, see whether we've hit something. Maybe that's falling mode FF. So to, once again, no space for comments in old basic code like this. Right, if f is larger than 2, no, that must be falling mode. So we'll have to figure out what ff means. Yeah, see, this basically sees. I'm just trying to see what it's incrementing here. F equals f plus. Yeah, so if you fall and it increments more than 10, then you die. Otherwise, you live. So that's how we die when you fall too far. Line 160 is once again looking at our feet for if our foot is black and on both sides of the character. We're not currently jumping, then f equals 3, which puts us into falling mode, and we immediately start falling. Okay. Line 170, looking for the colour 3 in the middle bottom of the character, and we're not jumping or falling at the moment, and our direction is 2, which is to the right. And we do a bit of a calculation there, and we go and v-poke a character. So that's so the platforms disintegrate. Yeah, we actually go and erase that particular character at that location. Else we look at a slightly different position and slightly higher, and we do the same thing. Because obviously this is written in BASIC, so it's a little slow, so it's making, I added an extra check in there to make sure that we weren't going to miss the character landing on a platform. Line 180 on O plus 1 go to 250, 190, 220, so we've got a little bit of logic there, and that's actually a go to, so we immediately go there. Line 190 is the second one of these that we jump to, so DO, we haven't had DO before. So B equals V, we're peaking on a particular section of the screen, plus 3 plus our level. I'm not really sure about that one. Oops. Yes, this has actually got fairly complicated code even for me back then. Yes, so there's 190 to 210 is one part of that particular thing. So there's 3 different things. We'll have to find out what O is later. It seems to be changing a particular value. Maybe this is the ball. O for orb. How about that? Orb? What do you reckon? Why didn't I use B for ball? Anyway. There's only 3 things though. You can go left, right. What about up and down? But it does seem to be moving something and then reversing the direction of it. So it's got like a starting and ending range. That has to be the ball. So all this code here, right up to where we've listed at the moment, is moving the our ball obstacle. Right, 250, BB equals BB minus 1. If it's less than 40, then sound, we make a little sound. If it's 0, then 310. Maybe this is our bonus time. BB will be our bonus time. So this is bonus time when it gets below 40. It starts beeping, warning you that you're running out of time. Line 260, if G, we haven't encountered G before. And we go and get a random we're poking a value into video memory, and it's a random thing. It looks like a random colour. Okay, well we've found our collision detection routine now. So once you enter it, we turn sprite off and go to 90 immediately. That doesn't make sense. This mustn't be a sprite collision routine, this must be a game over, and it's making sure it's turned off collision detection before we go back to the title screen. So line 280, we're drawing a box. getting this is basically displaying our score and checking whether we've got an extra man, playing a little tune if we've got an extra man, increasing our extra lives, and how hard it is to get an extra man. We obviously have a maximum of 6 lives, and then we return. Line 300 increases or displays our lives on the screen. And in this particular case, I've actually got the actual man, one for each life there, and that's why it's V-poking the characters onto the screen. So this is a very long listing. I hope nobody's fallen asleep out there. So line 310 sets some sound. This is where we die. Okay, so we make a zoop sound, decrease our lives with a little delay, display them, and if our lives are larger than 0, background 80 to start the screen again. Otherwise, line 320 draws our game over. Checks whether we've beaten a high score on the high score table, and if so, replaces it. And line 330 displays that we've otherwise go back to 40 and start the game. We haven't beaten high score. Line 330 we have beaten the high score, and puts up in a banner that we've achieved a high score. And there's actually a little animation sequence with our man here when we achieve a high score. It'd be worth actually trying out to see what happens. I really added a lot of detail to this game. Oof, that only just fit. And 350. Oh, okay, so this is a section where I know what it is. We're displaying the character set, and you move your little man around to select the characters as you type them, I think, or do you just type them in it? Yeah, anyway, it's making sure that what you're typing in is inside one of those characters. Actually doing a range thing would have been faster than this in-string command I've chosen to use here. Yeah, that's basically allowing you to enter your high score into the high score table. It's amazing. And line 360 is actually replacing that score and then jumping background to our title screen again. So line 370, this is our sprite collision detection routine. Turn sprites off. Then we need to go through our various shapes, which is probably our gold, and see whether what we've hit is one of the pieces of gold. Yes, we're increasing our score, not dying, so I take it that first one is detecting whether we hit a piece of gold first. Line 380, I take it X1 is our ball. No, it's the gate. So our actual end gate is a sprite as well. If our gold equals 4, we've got the 4 pieces of gold on the screen, then we've managed to do it. Otherwise return else 310. Now I take it, yes, okay, so if we've hit any other sprite on the screen, we don't need to detect it. So any of those little flower things, we just die. So we've gotten rid of the things that we actually want to do something specific with, and anything left over, we don't need to check specifically because all of those things kill us. So go to 310, that'll lose a life. So 390 is our end of level. So we play a couple of sounds, add some more points onto our score for how much bonus time we have left. And we play a sound as we do that, and we display it on the screen so you can see it happening. When we clear our sound and increase our screen number, and if it's less than 10, we haven't finished the game. If it's less than 10, then 80. What happens when we finish the game? Let's have a look. Right, the game just locks up. That's a bit boring, isn't it? It's a bit mean. Let's just set it again. Right, now we've got some subroutines here, which are very big. These are the ones that draw each of the levels. So we have to list less. Let's try that. Dust. Okay, so we set the amount of time on this particular screen. We set our starting X position and the direction he's facing. And then we have 4 statements going through and putting the characters on the screen, drawing each of the platforms and each of the yeah, going through put each of the characters, including the pieces of grass and everything like that. So as you can see, it takes a fair bit of code to just draw a screen. At line 430, we still haven't finished one. And we restore at 820, and we read in some, that must be all the sprite shapes, 820, and return. So all of that, there was actually about 9 lines of code just for one screen. And then line 460 is obviously our second screen. So I will keep listing. They're all going to be very, very similar. So what are we up to? 482. I'll still step through. I'm just having a bit of a look here. Yeah, and a similar thing, restore at a different point, 840, to get our data at the end there. That's the end of that level. And then we do the same thing for the next one. So that's the next level. And there's another level in the start of the next one. This is why the program's so long. I probably could have worked out a way of doing these from data. Okay, so we finally get up to here. So 730. This looks like sprite or character. This is probably our character data. Well, it could be our sprite data because we've only got very small sprites. They're only 8-byte. All the sprites are 8-byte except for our ball. Yeah, no, they're all our sprites. Should stop doing that. And this is our level data. So we're just about done. Oops. And that's the last bit. So each one of those sections, I think 2 lines worth, is basically placing all of the bits of grass on each of the screens. So I did use data for that. I probably could have used similar data structures to draw all the platforms at the end of the day. So it actually shows this game is using a generic engine to use detection by colour to, allow us to put whatever we want on the levels, and the game will react accordingly. So it'll be very easy to add extra levels to this game. It is a fairly big program already, but I'm sure there's still plenty of room left to extra levels. I probably could have had 20 levels, but I thought 10 was great at the time, and it is a pixel perfect, platform game, and it's probably infuriating enough as it is to get to the end. I should have been nice and put in you have completed the game screen though. Put everything else in, but it's a little. You can see it's a little more advanced than some of the earlier titles. It has a title screen that you actually enter your name into. Obviously, can't save that. It has a fair bit of sound here and there, and quite complicated mechanics, and it's even using tiles in a couple of places rather than just using the line drawing and other commands. So a very, very cool game. One of my more popular packs, this one, especially when we get on to the next program that's on this pack as well. Alright, I hope you're enjoying this series showing my games that I wrote back in the early 80s. And pretty much every single one of these games was written originally for the Spectravideo before the MSX came out, and then I later ported them to the MSX. Some of them would have been written when I actually had my MSX, though. I can't remember the particular ones. This is a later one. I do believe I wrote it for the Spectravideo first. Right, I'm Electric Adventures. Thanks to all my subscribers. Thanks for watching, and I'll catch you next time.